Hello. So today I have yet another Python creation. I made, you can see I made it yesterday actually, and then I sort of finished it up. Alright, that is today's date. How did that happen? Throwing date on it, that's funny. Well, started working on it yesterday, and that this is supposed to be yesterday's date, and finished it up today. And it's just a simple program that generates a word search. I guess it's really not that simple. A little long, but I was thinking today, instead of just showing off the final product, which I can also do, I will be doing that. So you can see it allows you to enter the board width, board length. You can put whatever words you want. It doesn't matter. But then you can see like it doesn't like that I put invalid characters. But then if I put like too long, it's gonna say, oh, it's too long. Gives the same error message every time, so maybe I should make some code that can differentiate that. But for now, it's just gonna give you the same error message. Poultry. You know, it's a good long word. Maybe non-affluent. Ultra regimented. I don't know if that's an actual word, but if it isn't, I just made it up. And it doesn't you don't have to write actual words. You can write whatever you want as long as it's short enough. So then enter the probability that the computer will force words to intersect. So when I go over the code, this will make more sense, but I'm gonna make that like fairly high. Then enter the probability the computer will generate filler letters based on letter frequency. So again, it'll make more sense when I look at code. I'm gonna also make that fairly high. And so now if I zoom in, so I'm really not used to being able to zoom in on the command prompt, but yeah. You can see we have our word search. It's this nice square. If you were to count it, I'm sure it'd be 16 letters long. We got the word non-affluent up there. And you can see it took our list and it randomized the order. So it's no longer in the order that we gave it. Oh, I think this is Class C. I don't know why whenever I demonstrate this, it seems to like stop doing it at like, oh, that's so mean. ULTR, and it's not even the word. That's funny. But it seems to like give up on diagonals every time I go to demonstrate, which I guess 4 words, there are 8 directions, so it's not going to go in every one of them. Ultra regimented. I mean, you can't highlight vertically, so it kind of looks like great when I do that, but it's fine. And then on our last word, poultry. Oh, here it is, poultry. Oh, that's why it was ULTR, because there's another word that has ULTR in it. That's funny. I didn't realize it did that. And you can see poultry was intersecting with passy, or I guess it's sassy. But yeah, so it's generated this. And if you look at like letter frequency thing, you can see that there's a lot more like N's and E's and T's. There's like a lot of T's in the obfuscation. So just like the random filler letters that aren't in any of the words. So that's because it's generating it based on the frequency that they appear in the English language rather than on just like pure random chance, like a 1 in 26 of any letter. But I only gave that 0.6 weighting, so then you also see a lot of like Q, and here's a Q, and here's a Q, and there's a lot of Q's going around, and like X's, there's 2 X's in a row. There's a lot of Y's and V's, I think, are pretty low down in terms of how often they occur. And then if we look, those didn't appear in our data at all, in our words to find. So those are just pure. Oh, and J's, a lot of J's. So that's just random. And then maybe like one or two of those are from the intentionally trying to make it look like English letters rather than just pure random. And we can do this again. I'm going to show off having a different board height and then width, and then the same thing happens in the other direction. So now I'm trying to think of like a 12 letter word. Well, I guess ultra regimented, right? That's pretty long. How long is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ultra regimented. So you might think, oh, that's too long. It's not going to fit long wise, but I would contend it fits vertically. So it can go down or it can go up. In my code, I made it so that it'll always do that. What else can we do? Jingoism. Regressive. Income tax. Let's say Philippines. Let's spell it correctly too. And what should our last word be? Let's say Roosevelt. Probability that they'll force. I'm going to try to make it force every intersection that it can. And then I can run through like how that goes. Letter frequency, I'll just say like 0.5. So yeah, you can see it's done it vertically. Here we have jingoism. Um, but the first word it gave us is Roosevelt. That's what it randomized to be the first word. It's just funny because it was the last word originally. Not that that matters because it's random, but where is it? Here it is, Roosevelt. So then now I would expect ultra regimented to try to use one of the letters from Roosevelt and like go off of it and like cross through it. Although with this particular word, I'm not really sure if it even can because it's so long. But as you can see, I don't think it did it. Let me just find ultra regimented. It shouldn't be that hard. There aren't that many U's. Ultra regimented. Yeah, you can see it did not even try. Well, I mean, it tried, but it didn't work to get it to intersect with this. I feel like maybe it would have been able to intersect with like ULT. No, maybe not. Oh, because it would have to go vertical or down because of how long the word is. So yeah, never mind. It wouldn't have worked. What else do we have? Progressive. So then you can see the word progressive is intersecting with the R in ultra regimented. Then if we look at income tax is going to be, I think, going into this O, but I guess it could be going into really anything. It could be going into this T or this T, although I don't think it has a room for that. Um, or it could be going into any of the letters in Roosevelt. Maybe I should get better at. Okay, here it is, income tax. So you can see it's intersecting in this E of Roosevelt. Then we have Philippines, which is right over here, which is intersecting the P in progressive. And then jingoism. Oh, jingoism is right here, which is intersecting the S in Philippines. So you can see how it's basically been like, okay, here's our word, the next word. Can we intersect? It tries it. It didn't work for actually ultra regimented. It had to go up or down, and Roosevelt was already going down, so it couldn't. So it just put it down somewhere. And then it was like, okay, progressive, can we make this intersect? And it's like, yes, we can with this R. And then it, you know, selects a random letter that it can intersect with, tries it, sees if it works. If it doesn't, it keeps going through the list in every direction. It tries every direction in random order. If it doesn't work, tries them again with the next intersection, the next one, next one, next one, next one, until it finds one where they can intersect. And then, it did that with income tax over here, intersecting with Roosevelt. It did that with the Philippines, intersecting with the P in progressive, and then jingoism with the S in Philippines. So that's maximum intention to make intersection. And it made pretty much everything intersect, except Roosevelt, which it couldn't, so it's fine. So this is the code, and you can see I've tried to make helpful comments. So, I have my name, date, description, like the AP Computer Science. My AP Computer Science teacher makes us write name, date, description on top of every assignment when we submit a program, which is not that often, admittedly. So, and then you got my imports. I used random, and then I don't actually think I need math because I used math. Let's see, I used it somewhere in here, and yeah, here. Math.floor I divided by 3, which I didn't realize, but Python actually does have integer division. So by default, it's just going to convert these into, I guess, floats or type float, right? Type float, yeah. Which then is going to be, whatever the actual value of 1 divided by 26 is. But then in something like Java, this would get interpreted as the integer 1 divided by the integer 26, which 1 can go into, or I guess 26 goes into 1 0 times. It just doesn't fit. So it would give you 0 as the result, rather than giving you 1/26. It's like if you did division, and then you had the remainder, and then you just ignored the remainder. That's what integer division does. But in this case, I actually don't want it to do that, so it's nice that I don't have to write like 1.0 divided by 26. But then if we scroll down here, in this case, over here, no, over here, there we go. In this case, I actually do want it to round down. So I use math.floor to round it down, but apparently you can just use double slash, so I guess I can go change that, but I'll do that later. In any case, so there's a lot going on. So I don't know if I need math in my importations, but I mean it's a nice thing to have anyway. You can look at weighted letter gen. You can look at unweighted letter gen. They both basically do the same thing. They have a list of every letter, which in this case I'm using a tuple because I don't need to change these values at all. So it's just every letter. In this case, it's in order by how likely they are to appear in the English language. I was about to say human language, which is based off of, you can see I got my link to www.3.nd.edu. It's a cryptography handout. So yeah, it's nice. Those cryptographers have supplied us with the letter frequencies down to 6 decimal places. Or I guess 4 decimal places, and then these two would be in the front as because they were given as percentages. But in any case, so it's got them all in order. It's got all the frequencies, and then it just cycles through 26 times. If a random number 0 to 1 is less than the frequency, it returns the letter at the position. Otherwise, it subtracts this amount and then moves on, subtracts this amount, moves on, subtracts this amount, moves on, subtract this amount, moves on, so on like that until it gets to the point where now it is actually smaller than this amount, and then it'll give us this. I'm not sure what term that is because they're not lined up, but you get the idea. And then this does the same thing, the unweighted letter gen, but instead of using the frequencies chart, it just uses 1/26th. So then this is going to be purely random rather than weighted. And then when we talk about, there are 2 things in the code that I do that pertain to that. Over here we have letter weighting equals next double, and then so that's when the program asks you this. What that actually does is it sets it to letter weighting, and then now if we go down here, we have letter weighting. So if some random number is less than the letter weighting, then we use the weighted gen, otherwise we use the unweighted gen. when we're obfuscating the board, or obscuring the board, I guess is the word I used. I don't know why I didn't use obfuscating. I feel like I would have done that. But anyway. And then same thing with forcing it to intersect is a very similar idea. We have, where is it? See, I thought all these comments would be helpful in locating things, but I don't know, it's not really working. But anyway, force intersect rate is here. We have n of the probability that it'll force the intersect. And then if we go down here, now it basically says try to force an intersection if a random number is less than the intersect rate. And then since the random number is 0 to 1, if the intersect rate is like 0.5, and it doesn't include 1, so it's 0 to, I think it's like 0.999999999, like 6 something. I don't know, I looked it up at some point. And so it'll generate a random number in that range. And then if it's less than the number that you gave the program, then it'll actually go and try to force an intersection. Hence what it says here. It generates a list of all the potential intersects. So what this does is it basically says I is the row that we're on, J is the letter in that row, so the column that we're on, and then K is the letter in our word that we're on. So for every letter in our word, if the letter matches the letter in the board, then we add this IJK, which will be the row we're on, the column we're on, and then the letter we're on in the word. So that'll basically that basically tells us like, oh, this is an intersection. It's in this position and it's with this letter in our word. So it's in this position on the board and it's in this position in our word, which we use then down here. This is to shuffle the list. So we take the list and then we apply more or less Knuth shuffling algorithm to make it just in a random order, because when we do this forward point in potential intersects, it's going to try and do it in order, which I don't want because then it'll favor a higher up row, it'll favor higher up, or I guess lefter columns, and it'll favor earlier letters in the word. But I don't want it to favor any of that, so I just randomize it. Then I go through them, then in a random direction. So this is how I shuffle the directions, is a number 0 to 7. And I know I could just use I in range, but I don't want to. So number 0 through 7, then we basically just go through the whole directions list and then shuffle them around, which I know I could also just use range 8 because this is always just going to be 8, but I also don't want to do that. Then for I in directions, now we go through the whole list of directions. We assume we don't have problems, set the point that we're going to start from. So we're going to start generating the word from the point of intersection. And then we actually say, never mind, we're actually going to start generating the word depending on what direction so we figure out what direction we're going in vertically, figure out the direction we're going in horizontally. And then we say, okay, if we're going to be moving like up, then we need to shift the point that we start at down so that the intersection in the word now actually occurs at that point rather than like later on. So that's why I saved the letter earlier. And then same thing here. If we're going down, we need to start higher up according to where the letter that actually is the intersect letter is. If that makes any sense. That's a little ridiculous, but you know. And then if we're not moving horizontally, we don't have to worry about it. But if we are moving horizontally, then we have to move. If we're going left, then we just move the starting point to the right so that the intersect actually lands on the given point. Same thing if we're going right, we move the start left. Then we basically just check to see if we encounter anything on the way. So this check is twofold. First is, do we go out of the board? because there's nothing up here that guarantees that our start point isn't outside of the board, or that guarantees that our that any point along the way isn't going to go outside the board. So we have to check, make sure we don't go outside of the board, don't give us an error in this part. So if any of these happen, then we know we have problems, we have to stop. If any of these happen, we know we have problems, we have to stop. And then we just shift over to the next point, go to the next letter, check for problems. If we don't have any, move to the next the next spot to generate the letter, then actually try to generate it and keep going like that. And then if that whole thing works, then we just break out of this for loop and we break out of this for loop. And then we can basically, then it'll skip all of this code because problems is false, and then it'll place the word into the board much in the same way as we placed the letter in the word when we were checking it, but just actually changing the value of the board. So then that's how it does it if it's doing it with an intersection. Then randomly is a lot easier. It just decides the direction it's going to go in. It figures out where it's allowed to be, and then it just tries to do it with the same checking algorithm. And then every time we do this while loop, we assume that we're doing it wrong, I guess. No, I guess we assume we're doing it right. And then if we hit something that's wrong, then we have to try it again. So we assume it's right, but if we hit something wrong, then we have to try it again. And if we keep trying it, and I've noticed through just like testing it, that the vast majority of the time, this attempts counter, so the number of times this while loop goes through, will not even hit 100 before it generates a valid board with I think I had 10 words that were like around 11 letters each, and I was generating it on a 12 by 12 board, and it wouldn't even hit 100. So 1,000 is being like way too lenient on it, really. But 1,000 doesn't take very long to happen. It happens quite quickly, so it's fine. But then we say, okay, if we exceed 1,000 attempts in this while loop, we keep trying it randomly and it just doesn't work. Then we say we're not done, reset the board, and then we break out of this while loop. And then if we're not done, we break out of this for loop. So then we would go back up and try the whole thing again. And then if we do eventually get through this whole thing, then now we've placed all the words into the board. Now it's time to obscure the board. So then for every letter that was originally in the board, they're all set up here to be question marks. So it's just a question mark. But we want it to be a letter because if it was just question marks, it would make it way too easy. So we make it a letter according to our random weighting, our letter weighting, or not letter weighting, depending on what the value you gave the system is. Then we can basically just do this, every row on the board, every letter in the row, check if it hasn't had a word placed on it is basically what this is doing. It's checking if it's in its original state. But if it's a letter, like if it's an actual like A or B or whatever, then it's not going to do this because it is part of a word that was generated, so it shouldn't. And then you can see according to letter weighting and the number that you gave it between 0 and 1, it will either do it using the natural like human language letter weighting. It's just specifically for English, but it works. And then otherwise, it's going to do it for just pure unweighted letter generation, which, you know, is also a valid method of doing it. Personally, I think the best way to do it is to have it like 50-50 or maybe like 70-30 with letter weighting because you want it to be weighted. But then you'll notice if I go up if I go back up to here, that especially as we get down towards the end, like Z, J, and Q are like super unlikely. Even like, I mean, okay, that's 1%, but this is less than a percent. Yeah, this is less than a percent. So the chances that you get these, what, X, Z, J, and Q are like so unlikely from the weighted generator. But if you use the unweighted one, it's a lot more likely because it's just 1 in 26. So if you have a word in your word search that has any of those letters in there, I would recommend using more unweighted because it'll be less obvious. Because like the chances that you get a Q are what, like 1 in 1,000, I think? Nah, it's about 1 in 500 for a Q or for a J. So if you have like jingoism in the list, like how I generated this, jingoism, there's a 1 in 1,000 chance you're gonna have a J that isn't part of the word. So it would be way too obvious to be like, oh, this is the only J in the whole list, so of course this is gonna be part of the word because, you know, it has to be. But then if you see here, like there's a J here, there's a J here, there's a J probably somewhere else too. Well, I mean, obviously there's a J here, but then now it's a lot less obvious. It's like, okay, let's look for jingoism, and it's like, oh, is it this J? No. Is it this J? J-I-E, that's not right. Um, hmm. Oh, there it is. So, you know, I mean, it makes it a lot more obscure if you use the random generator when your words have letters that are less likely. So my preference is like it's about zero 0.6, zero 0.7 is what I usually put in for that. But anyway, so that's sort of the general idea of how this program generates a word search. A lot of for loops, a lot of actually wait, is this a one, two, three, four? Wow, okay. So that's four fours deep. And I mean, even like up here, I have like a four inside of four, and this is a four inside of four inside of while inside of four. So there are definitely questions to be had about the efficiency of my code, but if I go, clearly it works. I can do, whatever I want. I can put in as many words as I want. They don't have to be actual words. Um, they can be just like fake. They can be, just whatever. If I try to put in like a word that has a hyphen, it's going to say, you can't do that. Because a hyphen would make it really obvious in a word search to find a word. Because it's just the only one that has a hyphen, like, of course it's going to be that one. But it makes it a little bit more difficult when you don't allow that. Let's spell that correctly. Um, what other words even exist? Trying to think of like long words because I made the board huge. Um, that's gonna be too long, isn't it? Um, uh, and then force words to intersect. I would recommend putting this at maybe like 0.8 because it's more fun when the words intersect, in my opinion. That's literally the only reason why I wrote that whole massive code to force intersections is because I was finding it very boring because none of the words were intersecting. Because the chances of it just randomly generating something that doesn't work versus something that just so happens to intersect, like it's way more likely that it's just not going to work. So to force an intersection makes it more interesting, I think. I'm gonna say 0.7 for that. And now you'll notice the program just ends when you finish generating the word search. So if you want to actually do the word search, I would recommend taking maybe like a picture of this and putting it into some other program where you can draw on your screen and stuff. This is just a command prompt program. I can't really, I mean, maybe I would be able to make something where you can actually like use, but at least for now, it's not going to be really a usable word search. And okay, here's PayPal. But yeah, I mean, there's only so much I can do really. And I think generating it is the more important part than actually playing it. Personally, I care more about generating it. Oh, that's what I should have included. Quotidian. Anyway, where's disestablishment at? Well, disestablishment is gonna have to start pretty far away from the edge because if it started too close to the edge, it would go over. So, I don't know. Pelt. I found pelt. That's almost the more fun part of playing a word search is just finding words that weren't in the original uh assignment. Like you just kind of look at it and you're like, oh, here's like, I don't know, pelt. Anyway, here is disestablishment under heliocentric. Heliocentric wouldn't intersect at any point because it doesn't start or end with any of the same letters. Which is kind of annoying. It's like, oh, look, it's a dull. And then I guess should also specify this is an 8 directional word search, which means it can go diagonal, it can go vertical, it can go like down and then go up, and it can go like, down to up and then right to left, You can have words that are backward. It's 8 directions. So there's no preventing like any particular direction. Um Trying to find an example of a word that's doing a diagonal because I don't think we really saw any of those. I don't know why we didn't. Well, I mean, I guess it's just random. I don't know. Did any of these go? Well, no, because this would be. Oh no, this one I think did have some that were diagonal. I don't know. I wasn't really paying attention. I was just kind of solving it. But like you can see, like income tax is straight and Philippines and jingoism and progressive and ultra regimented. I actually know all of these were vertical or horizontal. That's annoying. Generate more diagonal. But it's just random. So I don't think, I mean, I guess like it's possible that my code has bugs where it's more likely to find problems when it's going diagonal and then that, unfairly makes it less likely that it'll do that. But I don't know, here's a diagonal. Billiards. There we go. So that's an example of a diagonal. But yeah, I mean, that's pretty much all the features that my program has. I've been talking about it for 30 minutes. So I think that's a good point to lay it off. Um, yeah, getting some good work done with Python. A lot of sort of complex nesting of this for loop business. I really don't feel like it's optimal, but it works. It does the job. You can force it to intersect now, and it actually makes words that intersect better than it was previously. So there's obviously ways that I can improve the program, but for now, I think that's where I'm going to leave it. All right, have a nice day.